Let us look at another example of causal relationship forecasting. Khanna Fried Chicken, based in New Jersey, periodically offers 5-piece chicken carry-out boxes at special prices. Based on the historical observations of prices and corresponding sales, determine the regression equation, correlation coefficient, coefficient of determination, and the standard error of estimate. How many carry-out boxes can Khanna Fried Chicken expect to sell at $3 each? So in this example, Mr. Khanna has determined that the number of chicken boxes sold varies by the price that they are being sold at. So the lower the price, the higher the number of boxes sold. For example, as shown in this table, at $2.7, the number of carry-out boxes sold is 760. When the price increases to 3.5, the number of boxes sold reduces to 510. However, when the price reduces to $2, the number of boxes sold increases to 980. So here, in order to use linear regression, we will assume that there is a linear relationship between the number of chicken boxes sold and the price. And since the number of boxes is dependent on the price, we will consider the number of boxes sold as the dependent variable. So this becomes our dependent variable, while the price becomes the independent variable. And since we plot the dependent variable on the y-axis and the independent variable on the x-axis, our graph will look something like this. On the x-axis we'll have prices, and on the y-axis we'll have carry-out boxes sold. Now we have been given some data based on which, let's say, the data points come out as follows. So let's say these are the data points. Now we need to determine the regression line which can be drawn using these data points. So let's say this is the regression line. So once we have drawn the regression line, we can then determine the amount of boxes sold for any price. So if we have to find the number of carry-out boxes projected to be sold if the price is $3, so let's say this is $3, we can draw the line like this, and then this will be the number of boxes sold at a price of $3. Also, we can determine whether the choice of price is a good one for arriving at the forecast by using the correlation coefficient, the coefficient of determination, and the standard error of the estimate. So let us find out the regression equation for the regression line, and then we'll proceed to find out the correlation coefficient, coefficient of determination, and the standard error of the estimate. So this is the information that has been provided to us in this example. Our main goal is to arrive at this equation here, which is the regression equation. And in order to arrive at this equation, we have to find out the values of a and b. And the values of a and b can be found using these two formulas. So first let's find out the value of b. Now in order to find the value of b, we have to first find out the sigma of xy. So let's first find out all the values of xy. So 760 multiplied by 2.7 is 2052. 3.5 multiplied by 510 is 1785. 980 multiplied by 2 is 1960. 250 multiplied by 4.2 is 1050. 320 multiplied by 3.1 is 992. 480 multiplied by 4.05 is 1944. Now let's take the sum of these values. So the sum comes out to be 9783. So we have the value of sigma xy. Now we have to find out x bar, y bar and n. N is the number of observations and we have 6 as the number of observations. X bar is sigma x divided by n. Sigma x is the sum of all these values, so let's find that out. So sigma x is 19.55. Let's also find out sigma y because we'll need that to calculate y bar. So sigma y is 3300. So x bar is sigma x by n. Sigma x is 19.55 and this divided by n, which is 6. So this is equal to 3.258. Now y bar is equal to sigma y divided by n, which is equal to 3300 divided by 6, and this is equal to 550. Now next we have to find out x square and take the sum of it. So let's find x square. Now 2.7 square is 7.29. 3.5 square is 12.25. 2 square is 4. 4.2 square is 17.64. 3.1 square is 9.61 and 4.05 square is 16.4025. So let's take the sum of all of these. So the total comes out to be 67.1925. So now we have all these values. Now let's plug these values into this formula to find the value of b. So b is equal to sigma xy, which is 9783, minus n, which is 6, multiplied by x bar, which is 3.258, multiplied by y bar, which is 550, divided by sigma x square, which is 67.1925, minus n, which is 6, multiplied by x bar square, which is 3.258 square. So this is equal to, so let me pull my calculator here. 9783 minus 6 multiplied by 3.258 multiplied by 550 minus 968.4. So this is minus 968.4 divided by, so 67.1925 minus 6 multiplied by 3.258 multiplied by 3.258. This comes out to be 3.5. So denominator is 3.5. So this is equal to, since 3.5 is in the denominator, we'll make 1 by x and then multiply this by 968.4. So 276.28 with a negative sign. So this is minus 276.28. Now let's find out the value of A using this value of B. So A is equal to y bar, which is 550, minus B, which is minus 276.28, multiplied by x bar, which is 3.258. So here minus minus becomes plus, so this becomes 550 plus 276.28 multiplied by 3.258. So 1450.12. So this is equal to 1450.12. So now we can plug in these two values of B and A in this equation here. So our regression equation becomes y is equal to 1450.12 plus, so because we have this as minus, this becomes minus 276.28x. Now we have to find out the projected sales of carry out chicken boxes if the price is $3. So let us plug in the value of 3 as x in this equation and let's find out the projected sales. So let me remove some of this portion to make some space. So y is equal to 1450.12 minus 276.28 multiplied by 3. So 1450.12 minus 276.28 multiplied by 3. So this is 621.28. And since we can't have 0.28 boxes, we'll consider it as 621 boxes. So this is the projected sales if the price is $3 per box. Now let us find out whether the choice of price is a good one for arriving at the forecast. And we'll use the correlation coefficient, coefficient of determination, and the standard error of the estimate. So first we'll find out the correlation coefficient. Now in this example, I'll use slightly different formulas than I have used in example number 1 of causal relationship forecasting. So correlation coefficient R can be found out using the formula n sigma xy minus sigma x sigma y divided by square root n sigma x square minus sigma x whole square n sigma y square minus sigma y square. Now the advantage in this formula is that we don't have to do a lot of calculation. We can find out most of the values from this data that we have already calculated, except the sigma y square, which we can calculate right now. So here we know the value of n, we know sigma xy, which is 9783, we know sigma x, which is 19.5 19.55. We know sigma y, which is 3300. We know sigma x square, which is 67.1925. We know sigma x, and we can square that up. We have to arrive at sigma y square, and sigma y whole square that we know, which is 3300 whole square. So let's calculate sigma y square. So 760 square is 577,600. 510 square is 260,100. 980 square is 960,400. 250 square is 62500. 320 square is 102,400. 480 square is 230,400. Now let's add these up. So the addition comes out to be 219,3,400. So let us now plug in these values in this formula. N is 6 multiplied by sigma xy, which is 9783, minus sigma x, which is 19.55, multiplied by sigma y, which is 3300, divided by n, which is 6 multiplied by sigma x square, which is 67.1925, minus sigma x square. Sigma x is 19.55, and square of this value. Second bracket, which is 6 multiplied by sigma y square. Sigma y square is this value, so 219,3,400, minus sigma y whole square. Sigma y is 3300 square. So let me pull my calculator here. 6 multiplied by 9783, 58698. So this is equal to 58698 minus 19.55 multiplied by 3300. This is 64515 divided by, now let's move to the denominator. So let's first find out the first bracket. 6 multiplied by 67.1925 minus 19.55 square. So this is 20.9525. So 20.9525 multiplied by, now the next bracket, 6 multiplied by 219,3,400 minus 3300 square. So this is equal to 2270400. 2270400. Now let's find out the value for the numerator. So the numerator is 58698 minus 64515, which is minus 5817 divided by 20.9525 multiplied by 2270400 and square root So 6897.14, and this is equal to, so we'll make this as 1 by x and multiply by 5817 negative minus 0.843. So we'll take this as minus 0.84. So this is the value of R. So let me note down somewhere here. So R is equal to minus 0.84. Now let's move to the coefficient of determination. So next we'll calculate the coefficient of determination. Coefficient of determination is R square. So we can simply take the square of this value, which comes out to 0.7. But let me calculate this using a different formula than what I have used in the previous example. So the formula for R square is A sigma y plus B sigma xy minus n y bar square divided by sigma y square minus n y bar square. Now we have all these values, so let me plug in these values. A was 1450.12, sigma y is 3300, B is minus 276.28, multiplied by sigma xy, which is 9783, minus n, which is 6, multiplied by y bar square. Y bar is 550, so 550 square, and this divided by sigma y square. Now y square sigma is 21,93400 minus n, which is 6, multiplied by y bar square, which is 550 square. So 1450.12 multiplied by 3300, so 4785396, minus, because plus and minus becomes minus, 276.28 multiplied by 9783, so this is 2702847.24 minus 550 square multiplied by 6, so 1815000, and this whole thing divided by 21,93400 minus, so this is the same as this one in the numerator, so this becomes 1815000. So let's calculate the numerator first. 4785396 minus 2702847.24 minus 1815000. So this is 267,548.76 divided by 21,93400 minus 1815000, 378,400. and this is equal to, so we'll take 1 by x of this and multiply with 267,548.76. So 0.7 or 0.71, which is nothing but the square of this value r. So let us note this down, r square is equal to 0.71. Now let us move to standard error of the estimate calculation. So third is standard error of the estimate. So sigma y x, this is represented by the formula underscore sigma y square minus a multiplied by sigma y minus b multiplied by sigma xy divided by n minus 2. So let's plug in these values. Sigma y square is this value here, so 2193400 minus a, which is 1450.12, multiplied by sigma y, which is 3300, minus b, which is minus 276.28, multiplied by sigma xy, which is 9783, and this whole thing divided by n minus 2, which is 6 minus 2. So 2193400 minus 1450.12 multiplied by 3300 minus 276.28, and this is a negative value, multiplied by 9783. So this is square root 110851.24, and the denominator is 6 minus 2, which is 4. So this value divided by 4 and the square root, so this comes out to 166.47. So this is the value of the standard error of the estimate. So let me note down this value here, sigma yx is equal to 166.47. So let us now analyze these values. What do these values indicate? So the value of r can range from -1 to 1, and as we know, the strength of correlation is strongest towards -1 and 1, and both reduce as they move towards 0. So a value of r of -0.84 shows reasonable correlation between the dependent and the independent variables. The value of r square can range from 0 to 1. So this value of 0.71 indicates that there may be some other variables in addition to the price which may be impacting sales. And the value of the standard error of the estimate is pretty high if we compare with the average of the sales, which is 550. So this value is considered to be pretty large, which reflects possibly a lot of forecasting errors. However, if the manager is fine with this analysis, we have already found out the value of sales for a price of $3. So the sales had come out to be 621 carry-out boxes.